Okay, right. Yeah, we're still one shot, that's fine. Okay, so welcome to the next lesson on Pacman. So where we left off last time, we were trying to make as neat a map as we could. We were adding things like the dots and whatnot. So I've done a little bit more with mine. I've done two versions. So I've expanded my map so that this is pretty much where it was before. So if it was one, it was a wall and it drew wall. That's just some testing code. Don't need that anymore. So it could change it to blue and drew a rectangle in that position. If it was two, that was a dot. So it set the color to white and drew an oval that was aligned to be in the center by subtracting half the dot from the half the block size. Then if it was three, that's a large dot, the thing that makes Pac-Man turn the ghost blue and eat them. So that was the same code as this, except for it being a quarter of the block width. It was half the block width to make them a bit bigger. And I also did number 4, which is drawing a smaller rectangle for the ghost gate, the thing the ghost can move through, but Pac-Man can't. And what it ends up looking like is this. So this is what I've ended up with my Pac-Man thing. I've drawn a level that closely resembles the original Pac-Man one. It's got dots in all the places there are twos. It's got these big dots where there are threes. It's got blue rectangles where there's walls. Just to give you an indication of different ways you could approach it, I made a copy of this and did a few alterations. So I called this one a fancy map rather than changing all the original. And I've just made a few changes to the way it's drawn. Everything else is the same. The way it's drawn is a little bit different. I've done a couple of things. So when drawing the map, rather than just drawing a rectangle every time, I've got this. And what this does is, first of all, it checks whether or not a left wall would be needed, because it decides it's drawing the outlines of them instead. So if I'm at the left edge of the map, then I need a left wall. Or if there isn't a wall to the left of where I currently am, I need a left edge to it. Did the same for right, top and bottom. I also did some tricks to lighten the top wall, darken the bottom one, and do the same with left and right to give it a 3D-ish effect. It ends up looking like this. So that's the same map, just with a change on how it draws the walls. So instead of drawing a rectangle, it draws a top line, a left line, a bottom line, or a right line, and checks whether or not it needs to. So for this one here, for example, it doesn't need to draw the line, the right hand line, because there's another wall to the right of it. So that's what those checks are about. So little things like that. I also did something to stop it from resizing constantly, so it keeps its aspect ratio correct by always checking the minimum of the width and the height times the ratio of width to height to see which is the correct one to draw. So a couple of little extensions I did to it to try and make it look a little bit nicer. But I'm going to carry on from the original one here, which is just drawing them as blue squares and resizing with the window. Right, so make a new class, call this Pacman, and in here we are going to do a couple of things. First of all, for the attributes, we need to think what information Pacman needs to store about himself so that he can be drawn and updated in the right place. So we're going to store my X position, but, and this X position is not going to store it in terms of pixels, it's going to store it in terms of grid position. So if he's halfway between grid location 1 and 2, his position will be 1.5. So that's how we're going to store where he is on the grid. So he's going to store his position relative to the map, not just an absolute pixel position. So that'll be X plus. This needs to be double, obviously, because he's not going to be wholly in one grid or the other. He's always going to be partway between them. And we'll store his Y position as well. We'll also need to store the direction he's facing, because when we come to draw him, we need to draw the mouth on the right side. So private int, and I'll show you why this is an int in a second. Private int my direction. Now the direction, I'm going to use numbers to represent north, south, east and west, or up, down, left and right, whatever you want to call it. But so that I don't have to remember what those numbers are and refer to them later, and if I want to then change those numbers later, which I may well do, I'm going to use some static final ints to store that information. Now, static means it's not different for each instant. So if I make a Pacman, then I make another Pacman, these will remain the same. And final means it can't be changed later. So I'm going to put public static final int, I'll call it north, and then I'm just going to choose a number that will represent north. Now in this case I'm going to do degrees because it kind of makes sense, but I may well end up changing that later. So I'm going to say that it starts off facing to the right, so north is going to be 270 degrees. And I'll make a static final for each of these, and the convention is that these tend to be all caps. So south is going to be 90 degrees, east is going to be 0 degrees, and west is going to be 180. Now it doesn't matter a jot what these numbers are. If I had to call 0, 1, 2, 3 or anything at all, doesn't matter, because I'm never going to type these numbers in directly. I'm always going to refer to these variables. In the same way that when we're using a grid layout, sorry, border layout, we use border layout.north. Now border layout.north is just a string or an int to represent north, but we don't know what that string or int is, so we always refer to the static variable instead. I'm going to use the same trick here. So I'm never going to type in 270 degrees or 90 degrees, whatever. I'm just going to put pacman.north, pacman.south, pacman.east, pacman.west to represent the direction Pacman is going to face. So let's put in some default values here to make sure that when we run it, we don't end up with null pointer exceptions. So I'm going to say his default direction is going to be east, and that will refer to that one. It's actually 0, but we don't need to know that. And I'm going to put him in position 1 and 1 to begin with. So he'll end up in the top left corner. So he is. Okay. Now, the more complex bits that some of you won't like initially. I need Pacman to be aware of the map in which he resides, because when Pacman comes to sort out his movement, he needs to know if there's a wall to the left or right. He needs to know how many blocks there are. He needs to know how wide each block is, so we know how wide to draw himself. So we need to be aware of the map. So we're going to make a constructor to say that we can't create an instance of a Pacman unless we pass it a map. So when we create a Pacman, we have to pass the map that Pacman resides in, otherwise he can't be made. So I'm going to make a constructor. Remember, a constructor is a public method without a return type. So there's no void, there's no int, there's no nothing of that. It's just public Pacman. In this case, though, I'm going to say it has to be given a map. I'm going to leave that blank for the time being. We will come back and put things in later. For the time being, I'm leaving that blank. But that says I cannot ever do Pacman, my Pacman equals new Pacman. I would have to do equals new Pacman and then pass a map for it to be constructed. In fact, all it's going to do is pass the map up here. So I'm going to store this up here. I'm going to say private map, my map equals, all right, I'm going to leave that blank. It's going to have nothing in it. So I'm going to make a map to be stored there. And all this is going to do is say my map equals m. Okay, so to show you what that constructor has done, if I go back to my map now and I want this to store a pack to contain a Pacman, which it will because the map will have a Pacman on it, I'm going to go private Pacman, right, Pacman equals new Pacman. It won't allow that because it says the constructor Pacman is undefined. There is no default constructor. We have to pass it a map. So what I'm going to do is say this. Now this is where encapsulation feels like it's been horribly broken, because I'm passing itself to the thing I'm making, so it is aware of what's coming back. But in this situation, that does make sense because the map has to have a Pacman on, and Pacman can't exist outside the map. So the two are intrinsically linked. It's not a traditional class structure. So by making a Pacman and passing in the map and passing itself as the parameter, Pacman can now get to the information about the map by using my map dot anything that the map allows it to provide. Have we got any questions about that? That's something we haven't done before. Okay, I'm going to take that deathly silence as being everybody's very happy. Okay, so we have our Pacman that has the information about where he is on the grid and which way he's facing, and the map in which he resides. So I need a function to be able to draw Pacman. Now, Pacman is not a panel or anything, so there is no paint component on there to override, but I'm going to make a custom method called draw that then can be called from the map every time I want to draw Pacman. So I'm going to say public void draw on map, and it's going to require a graphics 2D to be posted. We'll have to import that. Oh, there we are, this capital D. Okay, and this is there. So when I come to draw this, I can pass the graphics 2D from my paint component method to this, and it will draw it using that graphics, which means it will draw. So I just need to say now how to draw it. So g2.set, for time being, I'm just going to draw a circle. G2.set color dot yellow.
So how do you import the graphics 2D again?
I just hovered over it and went to import. That's the line at the top if you need to add it manually.
Okay, thanks.
So I've set the colour to yellow, and now I'm just going to draw a circle in the appropriate place. Now, knowing where the appropriate place is kind of difficult, because we have Pacman's position, X pos and Y pos, but that's in just terms of blocks. It's how many blocks across he is and how many blocks down he is. We need to then get how big each of those blocks is from the map. At the moment, we can't do that because the map doesn't contain any facility for doing it. So I'm going to add something to the map that allows me to get this. So I'm going to... Oh, we don't need that anymore. That's something to the fancy one they can go. And we don't need that either. They weren't there last time. Right, so I'm going to put... These are adding some setters and getters that I'm going to need. Public... so I think, is it block width and block height to double? I think they probably should be. Yeah, I do. There's doubles there. Public double get. Right. And all that is going to do is return get width divided by my map dot length. So that's getting how many pixels is wide divided by how many blocks there are in the map. I'll do the same thing for height. Some great spelling of public. Try that again. That will get height divided by my map dot. Nice spelling of length. I'm doing great today. Okay, so that should get me how wide each block is and how high each block is. I've actually done that up here to get those. So at this point, I might as well, yeah, I did those up there as well to that. So really, I could just replace that with calling get block width because I've already done it. That would probably make it a bit simpler, but for simplest, I'm just going to leave it where it is at the moment. So now I have the ability to get the block width and the block height from the map. It doesn't like it. Why not? Oh, it's because Pacman's not saved. As soon as I save that, that will go away. Yeah, that's fine. Okay, so now I can get it to draw a circle in the appropriate place. I can say I can get the block width from the map I can get the block height from the map. And then I can use them to calculate where to draw a Pacman. So I'll say g2 dot fill oval. That's weird. But fill oval, and it's going to have its the first parameter is the x coordinate of the top left point, which will be its position here times the block width, because this is how many blocks across it is, and block width is how many pixels each one of those is. So it'll be my x pos times block width, and then my y pos times block height, and then the width will be block width, and the height will be block height. It's complaining about these. Should be a capital, my mistake. Now it should complain here, yeah, because these are all doubles and they need to be ints. So we're back to that nightmare from last time of doing lots of casting and rounding. So we'll say int math.round all of that. And need to do the same for the rest of it. Close all the brackets. Okay, so this now, draw a map, will take a graphics object and will draw Pacman in the appropriate place on the map that's given. So what I can now do back in map is, after drawing all these dots and whatnot, so this, I'll just put some code, again, some test stuff I don't need. Put some comments in to say the map background. Then after we've finished drawing the map background, we can draw Pacman. And all I need to do now to draw Pacman is say my Pacman dot draw and pass the graphics object to it. So using my graphics object, it will draw Pacman, and Pacman knows where he's stored, and that should be fine. So hopefully when I run this, there he is. There's Pacman sat in position 1 by 1 on the grid. Now if I was to update this, let's do a couple of tests. So let's say I was to set his x position to be 1.5 by 1. That should put him halfway between the first and second location on the grid. And it does. There he is halfway across. So now we can move Pacman around by changing his x and y position to be a fraction of a grid location of where he is on there. Okay? So what I'd like you guys to work on for now is drawing Pacman in the appropriate place, the way I've shown you there, and also adapt it so instead of it just being a circle, it actually looks like a Pacman. Get it to draw an arc, so look at fill arc, how that's done to get it to draw a mouth open or closed. Get it to put a little dot for the eye. Even better, can you get it to keep track of what animation cycle it's on, and every time it's asked to draw, it progresses the animation cycle and draws the mouth further open or further closed. So each time it draws, it moves, it opens or closes the mouth. But that's something I will show later on anyway. But for the time being, can everyone try and get it to draw Pacman facing the appropriate direction? So there his direction is east. So get him so his mouth will be open facing that way. If his direction is west, his mouth's open facing the other one. Okay? Okay, the second part of this, which I didn't record live, so I'll add this extra little bit on now to explain, is getting Pacman to respond to keys to move. So this isn't that complicated initially, because if we look in here, we've already got a direction being stored. So all we need to do is get it to update its x and y position dependent on the direction it's facing. So we'll add in a method to do that, so that every frame update this method can be called and it will update its position. So we'll call it public void update position. Doesn't need any parameters, we'll just call this every time we update the screen. And all it's going to do is check which direction it's facing and then update this appropriately. So first we'll do a check to say if my direction, the bracket, if my direction equals east, then we know we're facing east, therefore we need to move right. So we'll add a little bit to the X position. Now I'm going to do it in this case, so it always updates by 0.1. So it'll take 10 frames to move across a single block on that map. If you want to make this a variable so you can change your speed later on, that's fine. But for the time being, I'm going to hard code it in as 0.1. These are all updates we'll do as we improve it. So I'm going to say my X pars is increased by 0.1. Then I'll copy and paste that rather than typing it out again. And we'll say that if the direction is west, then we'll decrease it by 0.1. That'll move it to the left. And then do the same for north and south. So if his direction is north, I'll do it the way around. If his direction is south, then we're going to increase the Y position by 0.1. If the direction is north, we're going to decrease the Y position by 0.1. So that's set up to allow Pacman to move north, south, east and west, depending which way he's facing. Now every time we call update position, it will move his position based on the direction he's facing. Sorted. So to make him actually move, we just need this to call every frame update. Now frame updates are going to be sorted from the map because the map is the one doing all the drawing. So I'll just save that and we'll go to map and we'll add in a few things for this. So first of all, we need to use a timer. If you remember on the bouncing ball, we had a swing timer, which every time it counted down 40 milliseconds, it triggered an update. We're using exactly the same technique. So let's add in a timer. I think that's the right way around. Have a look. Yeah. Now, I've already imported this. So I'll just remove that to show exactly how it would look. You guys do it. So you put that in there. We have to import the timer. Now be careful here. Import the timer from the javax.swing package, not the one from utils package. They behave in different ways. We're using the swing one. So choose a swing one there. It will then complain and say that this here has to be an action listener. So I'm going to make this class be an action listener because we want to trigger this when the timer runs down. It has to be an action listener to respond to triggers. So implements. It's exactly the same system that we use with the bouncy ball. That will need importing, and then all the red lines should go away because now it's done that. So once this timer starts, it will trigger this map. We'll have to tell it to start. I'll come back to that in a second. We'll have to tell it to start. So in order to tell it to start, I'm going to do that in the constructor because I want it to start as soon as the map is created. So I'll make a constructor. Remember, a constructor runs as soon as a map is instantiated. And to make a constructor, you have to give the method the same name as the class and have no return type, so no void there. Map. So we'll just say my timer dot start. So that tells it that as soon as we make this, it will run this constructor and start the timer. So every 40 milliseconds, it will trigger this action listener, and it will trigger it by running the action performed method. Of course, there is no action performed method, and that's why this red line is here, because in order to be an action listener, it must have an action performed method. So let's add that method. That's gone away, and here it is down there, action performed. I'll get rid of all the text it puts in. And all I want it to do in the action performed is to tell Pacman to update his position. So my Pacman.update position, and then repaint. That repaint is necessary to tell it to actually redraw. So it's the position, then repaint tells it just completely redraw this particular panel. So Pacman's position will be updated. It redraws the panel and draws Pacman in his new position. Pacman will have moved. So that should be enough at this stage to actually see some animation. So let's run it. It's doing it, and it's moving 1/10 of a grid position per second. That's because for some reason I put 1,000 up here. What I meant to put was 40.
40 means now every 40 milliseconds, so 25 times a second, it will move 0.1 of a grid. So let's run that. And there we go. Now it's moving across. Of course, there's no collision detection or anything like that yet, so it'll keep moving, going straight over every wall until eventually it leaves the thing and it's gone. Okay, so we've got some animation. The final thing we want to do is get it to respond to keyboard inputs. It's not particularly difficult, but it's a little fiddly. In Pacman, all we need to do is change this value. If this value is south, for example, and we run this, now is moving down. So all we need is when the key is pressed to change this. Now we're going to do our key listener, our responding to keys, from the map class, not from Pacman, because some keys will alter other things not related to Pacman, so we're going to do them all in the map. So we need the map to be able to tell Pacman to change its direction. At the moment this is private, so we can't change it directly, so we need a setter. So let's put a setter in here. Set direction, in direction, and all it will do is say my direction equals that. Now later on we're actually going to update this, so oops, not double equals, we're going to update this so that as well as instead of just changing direction, it will check to see if there's a wall in the way and then refuse to change direction if there is one. But for the time being, we're just getting it to automatically change the direction, so we can call that from here. So now in the map, we're going to turn this into something called a key listener. So very similar to action listener. So implement action listener and also a key listener. And a key listener, just like an action listener, triggers a particular method in here every time a key is pressed, just like an action listener triggers a particular method here when a button is pressed. So this does it with keys. So this will need importing first of all. Then, just like an action listener, this will complain and say, I can't be a key listener unless I have particular methods. Action listener needs action performed to be added, and key listener needs, if we add them, 3 methods being added. One is key typed, that will be triggered every time a key is pressed and released. I'll get rid of all the extra text again. One is key pressed, which will be triggered every time a key is pressed down. The second it's pressed down, that will be triggered. And one is key released, which is triggered every time the key is released, as the name suggests. Now, even though we're only going to use one of these, key pressed, we're going to ignore the 2, they still need to be there in order for this to be a valid key listener, so you can't remove the methods. So in key pressed, every time a key is pressed, I want it to check which key is pressed and then call the appropriate set direction in Pacman. To check which key is pressed, I look inside this key event here. And this is how it looks. If e dot get key code is equal to, now the key code is a number corresponding to the code from the keyboard. We don't need to learn those numbers because they exist as static variables inside key events, in the same way that we made north, south, east and west exist as static variables inside Pacman, so we didn't have to remember the numbers for north, east, south and west. The same trick is used here in key event. So we'll check if key, whoops, event dot, and they all start with VK, so VK underscore up. So if the key event is VK underscore up, then we can just say my Pacman and call the one we just made set direction Pacman dot up. And there's our first one there. Not up, we called it north, south, east, and west, didn't we? North. I've misspelt direction. Oh, it spotted my misspelling, that's good. There we go. So now it calls the set direction and sends it north if it's detected up. I'll duplicate that for the other ones. So if it detects down being pressed on the keyboard, then it will set direction to pacman.south. If it detects left on the keyboard, it will call west, and if it detects right on the keyboard, it will set it to east. Okay, so that will, on the event of a key being pressed, will check what the key was and tell Pacman to change its direction appropriately. Now this won't do anything yet. If I run it, press keys, nothing. The reason is, just like an action listener, well, there's two parts you have to do. This is where it's fiddly. That just like an action listener, you need to set this as its own key listener. So I'll do that in the constructor. I'll say this dot add key listener, the same way we often do add action listener to add an action listener for a button. This. So this is its own key listener. So when this detects a key press, it calls its own key pressed method and then runs that. It still won't work though. And this is where it's a little awkward, because we have to consider something called focus, because only one component on any application can be listening to the keyboard at once. Think of it this way: if you're logging into a website, you click in the username box and you start typing your username, you don't want the password box to also be filling in at the same time. Only the username box is in focus and listening to the keyboard. When you've done that, you then click on the password box and start typing your password. Now the username box is not in focus, it's not responding to the keyboard, but the password box is. That's a design thing, because otherwise everything would respond to everything you press on the keyboard, and that'd be a pain. So we have to set this to be in focus. Now by default, JPanels, which this is an extension of, cannot be focused, only text. So we need to tell this to be focusable. This dot set focusable to true. By changing that, this becomes something that can be in focus, and because it's the only focusable thing in our application, it will by default have focus. And now it's got focus, it will be listening to the keyboard. So now when we run it and I press left, down, sorry, right, down, left, up, I can now direct my Pacman circle around the keyboard. So what I want you guys to be working on, and we will continue this in the next lesson, is drawing Pacman still so he's facing the right way. So when I press right, he faces that way, has a nice looking Pacman that moves that way, and up and down, etc. So next lesson, we're going to start doing some collision detection. Now that's quite complicated. We'll look a lot at that, and over the next few lessons, we'll get it to only move if there's space for it to move and not travel through the walls. But that's it. That's where we need to be up to at this stage. Hope that helps.